Hi, we are from At Home Tuition. In this video, we are going to see few examples on applications of direct proportion. The first example is a mixture of paint is prepared by mixing red pigment and base. If one part of a red pigment requires 75 ml of base, how much red pigment should we mix with 1800 ml of base? So first let's see what is given. So part of red pigment, they have given one part, so we can take it as 1 ml. Okay, then part of the base, okay, that is 75 ml it is given. Next, what we want to find? For 1800 ml of base, how much part of red pigment is required? So now let the number of parts of red pigment be X and number of parts of the base be Y. This we are considering it as X and Y. So now, as we have seen in our earlier videos, if we form a table of the given data, then it will be easy for us to find the proportionate values. So here I have formed a table with the contents part of red pigment, that is we have taken it as X and they have given it as 1 part. So I have taken X1 as 1. Then next is part of base in ml, that they have given as Y. That is we are assuming it as Y, and they have given for 1 part of red pigment we are taking 75 ml of base. So the corresponding base Y1 is 75 ml. So now the next part, they have given part of base as 1800 ml. So that is Y2 is 1800 ml. And we want to find the part of red pigment, that we will take it as X2. Hope you are clear how to form the table from the given data. So from the table it is clear that number of parts of base increases, the amount of red pigment also increases. So it will be increasing in the same ratio. So they are in direct proportion. So by definition, when two numbers X and Y are said to be in direct proportion, then the relation between two quantities are such that if we increase the one, the other will also increase. And if we decrease the one, the other will also decrease. So with this definition, we can write the relation for ratio X by Y equal to constant. That is K is the constant. Now we can rewrite this as X1 by Y1 equal to X2 by Y2. So now from the table of data, X1 is 1 and X2 is the one we want to find. And Y1 is 75 and Y2 is 1800. Now we can substitute all the values in this relation equation. So 1 divided by 75 equal to X2 divided by 1800. So X2 equal to 1 into 1800 divided by 75. So 1800 divided by 75, that is 24. So thus 24 parts of red pigment should be mixed with 1800 ml of base. This example is a machine in a soft drink factory fills 840 bottles in 6 hours. How many bottles will it fill in 5 hours? So what is given? Time taken is 6 hours and number of bottles filled is 840. Then what we want to find? In time 5 hours, how many number of bottles will be filled? So now let us take the number of bottles as X and the time to fill those bottles as Y. And as I said earlier, it is easy to find the relation and the unknown things if we write it in the form of a table. So I am writing in the table number of bottles as X and our time in hours as Y. So it is given 840 bottles and the time taken is 6 hours. So X1 is 840, Y1 is 6. And X2 is the one we want to find, number of bottles, and time for 5 hours we want to find. So as we know, the number of bottles increases, the amount of time required to fill the bottle will also increase in the same ratio. But in this case, the time in hours decreased. So the number of bottles should also decrease. So in the same ratio. So they are in direct proportion. So by definition, we know when two numbers x and y are said to be in direct proportion, then the relation between the two quantities are such that if we increase one, the other will also increase, or if we decrease one, the other quantity will also decrease. In this case, it is decreasing. So now we can take the relation x by y equal to k. So where k is a constant, and we can rewrite x1 by y1 equal to x2 divided by y2. So in this case, x1 is 840 and y1 is 6. So 840 divided by 6 equal to x2 divided by 5. So 6x2 is equal to 840 into 5 by cross multiplying, and x2 equal to 840 into 5 divided by 6. So x2 is equal to 700. So 700 bottles can be filled in 5 hours. Next example is a photograph of a bacteria enlarged 50,000 times attains a length of 5 cm as shown in the diagram. What is the actual length of the bacteria? If the photograph is enlarged 20,000 times only, what would be its enlarged length? Okay, so what is asked? The length of the bacteria, and if it is enlarged, it's given in the photograph is 20,000 times, and what will be its enlarged length they have asked. So length of the bacteria is 5 centimeter. Photograph of the bacteria enlarged is 50,000 times. So now photograph of bacteria enlarged is 20,000 times, and we want to find the enlarged length. So let the enlargement factor of the bacteria be x and the enlarged length of the bacteria be y. Now we can form a table. So the number of times enlarged, we'll take it as x. So that is x1 is 50,000 and the x2 is 20,000. So for 20,000, we want to find the enlarged length y2, and for 50,000, the enlarged length given y1 is 5. So now the number of times enlarged length decreases. Okay, so the enlarged length will also decrease. So by definition, we can write the ratio x by y equal to constant since it's a direct proportion. So x1 by y1 equal to x2 by y2. 50,000 divided by 5 equal to 20,000 divided by y2. y2 equal to 20,000 into 5 divided by 50,000. Cross multiplying and dividing. y2 is equal to 2 we'll get after simplification. So enlarged length will be 2 centimeter. Now we have to calculate actual length. Okay, we know that enlargement factor will be 1. So now the actual length be L. So 50,000 it's 5 centimeter, and for 1 it will be L. So L equal to 5 into 1 divided by 50,000. So that is nothing but L is 10 to the power minus 4 centimeter. So thus the actual length of the bacteria will be 0.0001 centimeter. Hope you have understood how to find the direct proportion, whether it is increasing direct proportion or decreasing direct proportion, and how to apply the direct proportion relation to find the unknown values. Thank you for watching this video.